I'm going to introduce our speaker. I'm very happy to have a keynote focused on data. We have Peter Carlin. We're lucky to have him. He's actually corporate vice president for the Azure Database Platform. Now, that is not just Azure SQL, although that's definitely part of it, but also the SQL database for Postgres and MySQL and MariaDB and other things that I'm sure Peter will tell us about. He brings over 25 years of experience designing, implementing, and operating SQL Server and Azure SQL through multiple product generations. Lots of us have worked through multiple product generations. SQL Server is about 30 years old at this point, and the technology keeps reinventing itself. It's very versatile that way. And he's also, executive though he may be, he holds an MS and a BS in computer science, both from Caltech. So, cool. Without further ado, here's Peter Carlin to talk about databases.
Thank you very much, Andrew.
Thank you.
Hello, welcome everyone. I hope everyone can hear me well. As Andrew kindly introduced, my name is Peter Carlin. My team designs, builds, and operates the Azure Database set of services and products. I hope you're having a great conference so far. It's great to have an in-person conference. This is my first in-person conference in 2.5 years, so I'm excited. I love databases. The Azure Databases team loves databases. But in fact, our job is to store and query data securely and reliably. But data is nothing without applications that use it, and the developers who build those data applications. So we really focus our job on making it as easy as possible to create database applications, to evolve them, to operate them. So today I'm going to talk a little bit about some of the things we've been doing to make that easier. And our goal is across all our database services to just make it easy to do things. So there's lots of reasons why people take data applications and are trying to move them and modernize them. And also lots of reasons why people are creating and evolving new applications. So these are some of the reasons I see driving that investment. And our goal, again, is to make it as easy as possible to realize these benefits. No one wants a project that takes longer than expected, or the application gets stuck after 2 years because it's like a mess and it's too complex to evolve and operate. So one of the things, the cloud has brought many wonderful things to this industry. And one of the things that I've really enjoyed about it is that the databases team doesn't just design and build systems anymore. Now we operate them as well. And so we have many opportunities to see, and it's crystal clear to us in so many ways, situations where it doesn't work as well as it should. And that's resulted in much faster innovation because, I'll be honest, if you wake an engineer up at 2 a.m. in the morning to fix something, you only have to do it twice, and then they fix it for real. You might say, well, before the cloud, you could have just listened to us better, and we would have told you exactly what was wrong, which is true. So I acknowledge that. But similar to that, the databases team now is responsible for building many more data applications than it was in the past. We need to do that just to run our own businesses, our own services. The monitoring and business analytics systems that our services depend on are basically complex data applications that recursively use our own data services. And so we've learned a lot from that as well. And that, again, is how we innovate and improve, by looking at what's hard about building data applications and trying to make it easier. So one of the biggest challenges that I see the data applications face is complexity. It's really challenging to build an end-to-end solution that stores data securely and reliably. It needs to provide real-time insight on that data, and it needs to provide governance on who uses that data and where that data is going and how it's being used. So to do all that kind of stuff, one has to be an expert in just way too many things. And it takes too much expertise to do all that. So for that reason, we've been working to put together what we call the Intelligent Data Platform. And we've brought together all the stuff in databases, in analytics, and in governance together in one place And our goal is to make it really easy to use these services together. So an example of that is Synapse Link. It's available now for Cosmos DB and Azure SQL, and it will be coming for MySQL and Postgres and all our services. You can think of Synapse Link as ETL SaaS. So its goal is to take the complexity of ETL and enable you to get the insight from that operational data and make it Azure's responsibility to make it be easy to get that insight. Now, that's our goal, and currently the system doesn't cover all those scenarios. In fact, it really only covers the really simple ones automatically. But it's getting more capable, again, as we look at how it's used and we learn about how to make it better. Similarly, Purview, you can think of as SaaS for data governance. Its job is to simplify the task of data governance. So that way you can govern access to your data across your entire data estate. You can track its usage, and you can control the flow of that data. This will get richer, and it will cover more databases and more ways to use data over time, and provide more insights on that data. We've added lineage, so you can track where did this data come from and how has it changed over time. We've added classification, so you can say these kinds of data are in these categories, and these kinds of rules apply to this data and not to that data. All our databases have or will soon integrate with Purview. Similarly, we don't just stop at the data platform layer. We're working to simplify usage of data across the entire Microsoft cloud. So an example of that is Dataverse, which is part of Dynamics 365. Dataverse makes it really easy to build data applications for business processes. Our goal is to make the database disappear. When you're using Dataverse, developers don't even know that underneath the covers you're using SQL or using Cosmos DB. It depends on the situation and how you use it and what you do. But you don't have to know all that stuff. So today I'm going to do a deep dive on our operational databases services and give you an idea as to what we're doing, what we've done in the past, what we will do in the future, to allow you to do more stuff with less effort. That's the goal. So let's dive in. So the big thing for me about Azure Database Services is you have choice. You can choose your favorite language, and Azure has you covered with a comprehensive portfolio, including relational, non-relational, open source. Azure supports a range of deployment options, popular stacks and languages, and a comprehensive set of engines. One of the things we really want to do is provide these services everywhere, from Azure to the hybrid to the edge. And through all that, we want to provide services, Data Migration Service and Azure Migrate, to enable you to move across these environments easily and quickly. So we don't yet have the full consistency across this portfolio for all application development experience. It's not the same for everything. We don't have the same capabilities for all of them. But that's what we're working towards. And as we do that, we're going to make application development in all these languages and environments way easier. Satya keeps saying that Azure is the world's computer. And I think of our database products and services as the world's database. Almost everyone on the planet interacts with these products and services every day. That's something we take great pride in, but also we are very humble and accept that it's our mission to securely store and query the data of the world. I say humbly because every single day we learn from what we see operating these services, and we continually see ways to improve. There are over 90 trillion queries handled per month by these services. There are over 20 million databases, which means 1 in a million things happen every single day. And our job is to predict those things, prepare for them, and be able to handle them so that you don't have to. So let's talk about a specific example of where people have been using our database services and putting them together in this way. The example is Walgreens. When you walk into Walgreens and fill a prescription, you're using the Microsoft Intelligent Data Platform. Every year across 9,000 stores, up to 40,000 prescriptions per second are filled. And to do this, Walgreens has a system that uses our data platform. So it uses SQL database, it uses Cosmos DB. It uses the intelligence services that are integrated into that data platform, such as Synapse Analytics, Data Lake Storage, Azure Databricks. And on top of all that, it has Power BI for visualizations and reporting. So this platform really helps Walgreens, its customers, and with the help of Azure, be able to scale and handle changes and unexpected events. So we've talked a little bit about the choices people have, and we've talked about the scale of Azure and an example of customers using Azure. Still, there might be the question, so why are people picking Azure? And for me, there's several reasons. The first of which is PaaS. We want to make our services richer and richer every single day. Number two, we want to provide this choice across the spectrum. So whether it's the getting started experience to the experience as the application matures, to the experience and the application has been around for several years and you need to maintain and be able to continue to evolve it despite the scale and complexity that it's reached. Again, we have a breadth of support for languages and drivers, and we want to make it easy to integrate that data and perform analytics across the whole set. We're trying to bring our developers to the cloud, but we're also helping people who want to use NoSQL or open source. And we're trying to build these developer experiences so they can be done quickly and easily. So there are millions of developers who use T-SQL and the SQL Server Engine on-premise. And we've been trying to bring that from the edge to the cloud. So our goal is a consistent experience for the SQL developer across all those environments. So recently we've invested in something called Azure Arc. And we've indeed recently released something called Arc-enabled SQL Server. What does that mean? That means you can take an agent and install it on any SQL anywhere. And on-premise, in another hyperscaler, running Windows, running Linux, anything. And without interrupting your application or your production environment, you can take advantage of the services by using this agent to connect to Azure that Azure provides. So for instance, threat protection, Azure Defender. We're integrating Synapse Link and Purview into all versions of SQL from the edge to the cloud. The goal here is to provide all the manageability and all the PaaS services that are available in Azure to people running our databases anywhere in the world. Now, obviously, we've got ways to go there, and this SQL from edge to cloud. For instance, we've previewed Arc for Postgres, and you'll see over time as all our database services provide this kind of multi-cloud and multi-environment capability. So if we look at Azure in specific, so we have invested a lot actually recently to make sure that Azure is the best place to run SQL and all of the database workloads. And that investment is yielding a lot of results. So we've done a lot of work on performance recently for SQL in the cloud. And I just want to read this to make sure I get the numbers right. But we've recently been doing a bunch of comparisons between Azure and AWS for SQL workloads. And one independent test reported that SQL Managed Instance is 5 times faster and 93% cheaper than SQL running on AWS RDS. And GigaOM found that SQL on an Azure VM outperforms SQL on AWS EC2 by 42%, while costing 31% less. And all this is because we've done a very comprehensive investment in performance. We've analyzed and made investments from SQL to the hardware that we run on, to the Azure infrastructure we use, like storage and networking, and make sure those all work well together. So for instance, during this effort, we improved the performance of SQL on new AMD chips by significant amounts, just by carefully analyzing what it takes to run those workloads well in the cloud environment. I think this is an illustration of sort of a principle I believe in, which is that the experts in something are the ones who run the best services of that thing. Obviously, Microsoft is the expert in SQL Server, and so it makes sense that we can run the best SQL service. And when people run into problems and our services run into problems, it's great that we can have the people who built the system and are experts in the system available to fix it. We're also growing that expertise in other database engines. For instance, Postgres. And we believe that as we become more and more expert in things like Postgres, and even though our philosophy is to contribute everything we do back to the Postgres community, we can still offer the best Postgres service because we will have the most expertise in Postgres. So as going forward, as we continue to invest in performance, we'll be publishing more and more benchmarks demonstrating price and price performance leadership for all our databases. So performance and price performance aren't the only areas that we're focused on improving the experience for database applications. So I'd like to welcome Aaron Stellato to the stage to discuss investments we're making to improve Azure SQL developer experience. Aaron?
Thanks. You. Hi, everyone. I'm Aaron Stellato. I am a PM on the SQL Experiences team, and some of you may think of us as the tools team. But I want to clarify that it's not just tools. It's not just Management Studio and Azure Data Studio, which I'm sure you all love as much as I do, right? But it's also SMO and PowerShell and DAC effects and the portal. So I'm really excited because I get to share some of these developer experiences with you, because in my role as a PM, I hear a lot of feedback from the community. And the great thing is that I get to work with folks in the feature teams across Azure SQL to then take this feedback, incorporate it, and then surface it back to you in functionality. So we know that developers across the spectrum are tasked with accessing, manipulating, moving data into, out of, within your ecosystem. And it can be really challenging, right? To get seamless access to that data that is then integrated with numerous services. And we also know that supporting today's modern DevOps lifecycle can be a beast, particularly in a cloud environment. And so we've made some recent announcements that we hope are going to make your lives a little bit easier. So in public preview, we have a new local developer experience. We've got SQL bindings for Azure Function Integration and new T-SQL JSON capabilities. We've also announced in private preview a new HTTPS API endpoint store procedure, which is built into the engine. And finally, we're excited to share the general availability of Azure SQL Database Ledger. And I'm going to talk through these so that you can start to think about how you're going to leverage them once you leave here and get back into your environment. So we'll start with database DevOps. You need to be able to develop without connecting to your Azure SQL database, right? You want an offline solution. And the Azure SQL Database local development experience leverages the Azure SQL Database emulator and SQL projects. So the Azure SQL Database emulator is a containerized database to which you can publish a database project offline and then test against while you develop. So you have a complete offline inner loop to work against, and you don't have to work about developing in production, right? Accidentally making changes in the live database. And then once you're done with testing and you're ready to deploy, you can take that project and you can either publish it directly as a new database in Azure SQL, or you can push that project to a Git repository where you can trigger additional steps of a deployment pipeline as part of that outer loop in the development process. So SQL projects are huge, right? And your database code is handled then in the same manner, the same process as your application code. And a common example here would be pushing the project to a GitHub repository that leverages GitHub Actions, and then you're either automating that deployment or applying schema changes to an Azure SQL database. And then the Azure SQL Database emulator itself can also be used as part of your continuous deployment, continuous integration and continuous deployment process to automate database validation and testing. Moving from that big picture of deployments down into the details of actually moving data, chances are your application handles some JSON data. Hopefully not XML, right? I fear XML. I'm much more friendly with JSON data. We're much closer friends. And those of you that work with SQL Server and want to use T-SQL, right, as developers, and so within T-SQL, we have to provide capabilities to process that JSON data. And we've heard that request. And so in public preview, we have both new and enhanced T-SQL function support for JSON capabilities. Specifically, for these functions up here, is JSON has been improved, and then the other 3 functions are net new. In addition, right, these are supported in Azure SQL Database and SQL Server 2022 on top of the JSON functionality that's already available in earlier SQL Server versions. While we're on the topic of functions, let's talk about Azure Functions. I want to make sure that you know about these. Developers love Azure Functions because they provide a serverless solution to use with cloud applications. Connecting Azure Functions to Azure SQL has been challenging and time-consuming. We have absolutely heard that feedback. So we're excited to provide an integration with the Azure SQL database that includes SQL input and output bindings and support for .NET, Node.js, and Python. And this should reduce the time that it takes for you to develop solutions with Azure SQL and with Azure Functions. And finally, the landscape across which you have to move and manipulate your data just continues to grow. Gone are the days where we had a single database on-prem and an application that connected to it and users would input data and then read it. Some of you might remember those days, right? It seems like so long ago, right? Now you have to integrate data with one or many other services, and you need innovative methods to do that, which are very efficient and very easy to use. So, enter REST endpoints, right? Most services support REST endpoints, and so we now provide a system-stored procedure within Azure SQL Database that can push data from your database to just about any REST endpoint that you can think of. So you now have the power of T-SQL to copy or move data to machine learning services, to Event Hub, or any REST endpoint that you create. You can even activate workflows for Azure Logic apps or notify SignalR websites, all integrated within your SQL code. As a reminder, this is in private preview right now, but if you're interested in using it, you can sign up for the EAP program. The URL is up here on the screen. If you can't get it fast enough, find me afterwards. I'll get you, make sure that you have that. So this is a real high-level overview of how we're working to improve the developer experience for Azure SQL Database. So I'm going to ask Drew to come on out and put this all together in a quick demo.
Awesome, thanks, Erin. So we've been adding a number of developer-focused features into Azure SQL Database, and many of them are applicable to the family of Azure SQL and SQL Server. For the first slide that you saw there around DevOps, tomorrow morning at 9:30, I'm going to do a whole session on some of those enhancements and how you can incorporate your SQL schema code into your full application development lifecycle. I am going to get us back on track in terms of timing as much as I possibly can in this next demo that's going to dive into some of the integrations for SQL Database. You have an application that's writing to a database, and you need to add some geocode information. You want to make it more useful. So what we're going to do is we're going to take that existing database and bring it into a SQL project. So I've already done that. We've got this super simple database. I know, it's fake. It's a work orders table, and there are some columns that the application is entering, the description, and then this location. It's basically an address that someone can type in. But we want to fill in latitude and longitude. We're trying to build a mapping capability on top of that. With a trigger on each new row that's entered, I'm now going to be calling SP invoke external REST endpoint. So this is a stored procedure that's able to call out to an API, and it's expecting JSON, so I'm going to use some of the JSON capabilities of SQL to bring that in. Now, when you're doing a trigger on a row being entering, some of you are going, oh no, this could be very dangerous. We're going to be careful about how we build that. So we've got our database code in the folder with our Azure Functions code, and I'm going to set up an Azure function that has used the durable orchestration framework. So it's a template that you start with that brings a number of capabilities, including the ability to get an invocation. So it's going to get that HTTP request from your SQL database with that body that we see there that's got the row information, and it's going to start the processing and return immediately back to the database. So it's not going to block that database call. It's just going to say, yeah, I got you. With that processing, however, that then can happen beyond the fact, we're going to go ahead and get that location for the coordinates. So we're going to call out to an additional service, just using the Azure Map services, saying, hey, I have this address. What's the latitude and longitude? This isn't a whole lot of code, and we're really starting to tie some services together. Now, I want that latitude and longitude back in the database. Instead of bringing in SQL client and opening a connection and doing all that results handling, I'm using that SQL output binding to add that input value to that object that's being added to the database. So all within this single file here, we've gotten the data from the database, we've used it in another service, and then we're parsing it again. I'm going to mock the application inserting data with this SQL notebook. When I run this SQL notebook, it's going to insert a few rows, and then it's going to immediately check what the table has in it. So when I run that, the rows insert, and then we scroll down to the table, and we'll see empty latitude and longitude. The application just entered the summary information. It didn't get the coordinates. But the Azure function ran immediately after and has now populated the latitude and longitude. So within that period of time, we were able to enhance our data. Now let's use this data in another API. We're building an application on top of our database. We want to get data out of our database. So this is where we can leverage SQL bindings even further for Azure Functions. So we have this work orders table. We want to return all of those columns to a website or a mobile app. We've got the SQL project, and then we've got the Object Explorer, and I can just create an Azure function for it. We had input bindings now, which is going to bring data into the Azure function. The output binding that we had earlier takes data out of the function into the database, so we're going to use that input binding now, and it's generating the templated Azure function for us. With this SQL input binding, we see the decorator there on line 17. It's running the query select star from DBO work orders. You can make that as fancy of a query as you want. Maybe you do stored procedures more in your environment, so that command type where it says command type text, we're going to change that in some instances to stored procedure. So you'll see that it gives me the IntelliSense for that. And then you can give it a stored procedure name. In the interest of time, we're going to stick with just this boring query so you can get the gist of this. But this is literally all you need to return the result of that query back to your application. Hitting F5 to go ahead and stand up the Azure functions here in the local functions runtime once that builds. All right. So this is running functions locally. You can use the Azure SQL Database local emulator locally as well. We see the new endpoint that we just generated, the list work orders. And I'm just going to run this HTTP request locally to prove to you that we really are getting data out of SQL Server. So this is like literally the rows that we just entered a few minutes ago with the latitude and longitude that was generated based on SP invoke external REST endpoint. Like that data itself is now there, and we just pulled it out with an Azure function. So that was it. I think we're getting through things pretty quickly. I know that was a lot, so I'm looking forward to your questions in the hallway. I'm happy to bring Peter back out here to recap some of the developer experiences across all of the database services.
Thanks, Drew and Aaron, for telling us about all the great things that you can do now with Azure SQL Database and making it easier to build applications. We're not limiting our investment in improving the developer experience to Azure SQL Database. For example, Cosmos DB also has a local development environment. And Aaron told you about the Azure Functions integration in SQL DB. In Cosmos DB, you can use an Azure Functions trigger to leverage the Cosmos DB change feed and process data for reliable event detection or whatever you need. Similarly, we recently released enhancements to Azure Data Studio to support MongoDB, and we'll be later this year releasing one for MySQL. As I described earlier, we'll be integrating all of our databases with Synapse and Purview. And we're investing to bring great software design experience to every developer, especially those who are new to our services. So for instance, we have a Try Cosmos DB experience that we recently released. And I encourage you to try it out. Its goal is to be really fast and easy to use and easy to get started with. So let's talk about performance, scalability, and availability some more. Making these kind of things just work for applications is our goal, and that means we have to be continually innovative. Performance isn't just about raw power. It's also about the ease of achieving that and making that just work, whether it's in the creation of the application or its evolution and operation. So, one example of what we do to make performance just work is in capacity management. How many cores, memory, and I/O should your application need? We've invested in AI-infused models that look at workloads on-premise, and knowing about the relative hardware that it sees on-premise versus what's in the cloud makes recommendations about what to provision to meet those workload needs. Even better, we are making all our databases serverless. So that means, what does serverless really mean? It means that Azure takes care of capacity management for you. Scaling the resources available to the database so that whatever it needs, whenever it needs it, those resources are available. Now, underneath the covers, that requires a very deep investment in resource management and sharing of those resources and moving resources, moving workloads and or resources to where they're needed. But all our offerings now have serverless or similar forms like burstable. And at this point, about 1/4 of our usage is serverless, which I think is great. And I would like it to be 100%. So, these are our fastest growing offerings. I definitely encourage everybody to, by default, use serverless for all your applications, and help us drive that up, because that really gets us to the point where the experience that we see and the experience that you see is tied to the usage, which is tied to how much it costs, and that gets the economics right and the incentives right for everybody. Another example is query intelligence. Query processing is really complex. It's really powerful. It's Turing complete. You can actually do any computation you want in the database. You could do Bitcoin mining in databases. I don't recommend it, but because they're not optimized for it. And it's in fact too easy to build really complex queries that don't work well, or that they work great all the time except one time in production, some data-dependent feature makes the query, perform poorly. So what have we done to help do that? We've built a bunch of what I consider It Just Works query intelligence features. So one is called APRC, Automatic Plan Regression Correction. And what that does is that it looks at what the query plan is and what, for instance, a new query plan would be, and it modifies it or reverts back to the best form of it if it sees a regression in it. So it's constantly monitoring the runtimes of various queries and changes in those runtimes and selecting the best query plan for the best situation. And all that is possible because of the scale of the cloud, the telemetry from the cloud, and our ability to analyze that. Similarly, there's a long-standing problem. Actually, I first saw it back in 1998 when I was trying to optimize JD Edwards on SQL Server, called parameter-sensitive plans. And basically that is that, if you're trying to pick out some characteristics or some, say, people with characteristics in Los Angeles, it's very different just because of the scale differences from picking out that right set of people meeting those characteristics in, say, Poughkeepsie, Maine. And that means that often you need different query plans for different scenarios and different parameters when otherwise the query is the same. So we've added parameter-sensitive plans, which means we can keep track of multiple query plans, and the system automatically figures out how many different query plans you need based on the different sort of categories of query plans that get generated based on the different sets of parameters. So the result of all this complexity that you don't have to worry about is the applications that just perform better with less gotchas and less work from the developer. So these are long-standing problems in databases. And it's just wonderful to me to see that Azure enables us to tackle these kinds of problems and solve them after so many years. We can learn from the customer experience, and as we see the scale, build these solutions and evaluate them, we can iteratively improve them, and then we can make sure that those are available everywhere. So all these improvements I talked about, parameter sensitive plans, APRC, those are available in SQL Server 2022. As they improve, it will automatically be propagated to SQL everywhere. An example looking forward, we're now investing in improvements to how lock management works. So we can auto-identify cases where there are hot spots in the application and optimize the behavior to maximize efficiency and throughput. So I look forward to coming back in the future and telling you about those enhancements. Security is really important. It's one of our fundamental goals to store and query data securely. And security can create complexity. Security that requires exact configuration and expertise isn't really security. It's just complexity and insecurity, in fact. So our goal is to make security just work. An example of that is our investment in Always Encrypted. Before we released Always Encrypted, you could actually do the same thing. You could stitch together an attestation service. You could be very careful about what kinds of queries and how you stored your data, and store it encrypted and bring it back to the client and write code that in the database manipulated the encrypted data. You could do all that. But Always Encrypted all wraps it up and makes it easy to do. And it's now available for both SQL and Cosmos DB. And going forward, it will be available for all our database services. So our work on security isn't limited to existing types of applications. We also want to enable new types of applications. So we want to tell you about a recent addition, which is ledgers for Azure SQL Database and SQL Server 2022, and going forward, other types of databases. And so to do that and explain more about that, I'd like to welcome Barb Ward to the stage. Bob doesn't really need any introduction. He literally wrote the book, and not just one book, but many books on SQL. So I'm honored to have him on stage with us to discuss the kinds of applications that Ledger enables.
Thanks, Peter. Appreciate it. Thank you. So today, as a developer, you may be thinking in terms of, could you consider using blockchain technology for your applications? Why would you do that? Because you're looking for scenarios where you need to have trust of data across multiple parties without a central authority. The problem, many blockchain technologies today require decentralization and distributed algorithms that may not perform very well or lack data management capabilities. So, a couple of years ago, we got together with the research team at Microsoft Research and invented a technology called a SQL ledger. We decided to put blockchain technologies inside SQL because it turns out SQL is pretty good at that performance and data management capability type scenario. So consider this situation. As a developer, without writing any new code, you can declaratively tell SQL, I would like something like a ledger table with a T-SQL syntax, something called an updatable ledger table. Out of nowhere, all of a sudden, by default, you get built-in history and auditing of all changes made to that table, including who made the changes, when was the change made, and what kind of operation was it. In addition, you get like a view on top of this history at any point in time to see what this auditing looks like. Now, because we're using blockchain technology, we also have something called a database ledger inside the database, which calculates crypto hashes of all transactions across all ledger tables, kind of like a blockchain. Think of it in a way as checksumming what has happened inside these tables to make sure you're ensured that there's no tamper that's occurred against the tables behind the scenes. Now, in addition to that blockchain, we have something called a digest. A digest, think of this as like a hash of a hash. It's a checksum of the blockchain inside the database, but that checksum is stored outside of SQL. So now you have this independent verification of tamper evidence of what's going on in the ledger. So you have built-in auditing inside the system. You have a blockchain as a way of checksumming what these transactions look like, and a separable digest to verify. So any party, remember we talked about multiple parties, could go use a digest at any point in time and verify that the data is trusted. Now, in addition to an updatable ledger table, we thought of there were scenarios where you would want to build a table as a ledger table, but only allow inserts. So think of it like a journal. Like I'm only allow actual new things that come into the system to be allowed, and no one's going to be able to go in and actually change the record of that, perhaps maybe a malicious DBA, to change the history of what happened. So I think the best way to look at this technology, all built inside the database, is to show you a demonstration. Now consider the scenario. You have this multi-party situation. You've got a supply chain, and multiple parties in the supply chain need to all trust data without a central authority, but they'd like to use a central system like SQL. So think of a company that produces ice cream. Multiple parties in the supply chain for ice cream, and as you can imagine, temperature of the ice cream is critical. So this Power BI dashboard shows you temperatures across various parts of the chain, including shipping companies and the farm, and we've detected an anomaly that's occurred right here with one part of the supply chain from the shipping company, the temperatures in Celsius. Here is an Azure Data Notebook showing you how to use Ledger. We have created a table, and we've got special syntax now added to this table to declare that we want a ledger table with, in this particular case, append only. And look at the columns I'm using. I'm showing you who's responsible for part of the supply chain, what is the temperature, and is it in compliance with the temperatures needed for ice cream to keep the ice cream product safe. I've declared right here with this simple extension that I want a ledger table. And just by executing this, all of this magic behind the scenes in the database has taken place. I've got history information of my ledger, and I've got my database ledger for my blockchain. I can run a query right here to see that this particular part of the shipping company and the supply chain was out of compliance with this temperature right here. Well, let's pick a scenario where a malicious DBA is hired who has access to this database and wants to go update that to tamper with it to show, oh, actually they were in compliance, the temperature was actually correct. Notice that the T-SQL update statement fails. That's because we marked the table append only. And guess what? If that DBA tried to drop this table, we would save a record of the fact that the table was dropped. The only way to remove its existence is to drop the entire database. So not only that, I told you about the fact that we have a view on top of the history of the ledger. So I can run this query, which is using what we call a ledger view built by the system automatically, and I can join it with that database ledger thing I talked about, right, that has all the blockchains in it. That's where all the transaction details are stored in something called a transaction ID. So think of almost like a temporal table with auditing capabilities joined with hashes of transactions together so I can get rich information about auditing on my system. You can see here, I can get the timestamp of when the transaction occurred, any change. Remember, they're all inserts in this case, and I can find out who actually initiated the change, which is a SQL principle. In this case, I can see rich information about what user made the change, when they made the change, what was the operation. We talked about digests. Azure Database provides a service to automatically store digests for you. Remember that independent verification? So by selecting this, we will store digest in either Azure Storage or Confidential Ledger for you automatically. So you can go back at any point in time, as you see in this example, and verify the ledger. So let's say somebody tried to really tamper under the covers with this database. I can use the digest now to go in and look at the fact that the system is valid. But here's the beauty of it. Because digests are separate from the database, anybody in the party can do this verification and trust that the data is valid. You may be asking yourself, like, is anybody really using this? Well, how about Lenovo? Lenovo has done a study with us where they're now using Ledger as part of their supply chain to include parts and shipping as part of building computers for folks worldwide. And they use Ledger to get that multi-party supply chain trust, again, across different parties without a central authority, but now a central system. And that's Ledger and SQL, both available in Azure SQL Database and SQL Server 2022. Let me go ahead and bring Peter back on stage and hear what else is going on in the world for developers for SQL.
Thanks, Bob. One of the things I think is really interesting about Ledger is to think about what are all the cool applications and new things that we haven't even imagined are going to be able to be built with Ledger. This example that Bob talked about, Lenovo. So for instance, I think it might be cool if somebody built an application that made it crystal clear and no one could tamper with the evidence that the Seahawks are the best football team. Bob's a Cowboys fan, if you guys don't know. Okay, I want to talk a little bit about scale now. Another dimension for ease of use is scale. A promise of the cloud is infinite elasticity, whether that volume of transactions or its size of data or its amount of compute needed. So with all our services, our goal is to make sure that you're in control of the scale and you get to decide and you get predictable performance no matter what scale you pick. So for instance, SQL Hyperscale now enables workloads to scale up to 128 cores of write workload and up to thousands of cores of read workload, all over up to 100 terabytes of data. And we've just released named replicas on Hyperscale, which enables you to manage the usage of those up to 30 replicas. And we'll soon be adding serverless support for Hyperscale. As you saw earlier, in some of the statistics I showed, our largest Hyperscale database is now 97 terabytes, which is getting very close to that 100 terabyte limit. So of course, we'll be supporting that customer as they grow and continue to enhance our scale limits. I talked earlier about how serverless is really, you can think of it as SaaS for capacity management. It's also SaaS for scale. So, with serverless, you don't have to worry about when to move the workload to a different size or different hardware. And I look forward to when, going forward, serverless will do things like figure out when you need to add read replicas or when you need to partition so that your system will scale better. Availability is about ease of use, really, when it comes down to it. And that means not worrying about when the database is available or how to ensure that it is. So all of our database services spend a lot of time investing in making sure that upgrades are minimal impact, North Star zero impact. I don't think we're ever going to get there. And that applications don't have to worry about when upgrades occur. We do a lot of work on the infrastructure to do things like detect when low usage points are and upgrade during those times, or systems that automatically redirect connections to secondary replicas during upgrades, or for instance, systems that detect that upgrades are stuck and need intervention and sometimes apply various automatic mitigations to keep the system up and running. And where necessary, figure out what's going on and make sure the right expert can come and fix it. Availability also includes things like it's not just the upgrade that can cause impact. It's 2 to 3 days after the upgrade that you run that query that regressed its performance due to some change in the system, whether it's in the operating system or the database or any of the infrastructure in between. And so systems that look at that performance both before and after and automatically detect when there's been a regression and what the cause of that regression is and it's correlated to the upgrade and can roll it back automatically and keep track of what's going on. Over the last 5 years, all this work has yielded definite improvements. The average downtime on the monthly upgrade that we do in the cloud for Azure SQL is now less than 1 second on average, and for 99% of databases, less than 18 seconds. 4 times fewer databases don't reach their SLA availability than 2 years ago, and this kind of improvements we're applying to all our systems. And this kind of investment yields investments and yields benefits for on-premise users as well. Features like in SQL Server 2019, accelerated database recovery and distributed availability groups. All those came about because of the learnings and the lessons from running in the cloud at scale. We invest a lot in open source as well. These are our fastest growing services. And our goal is to bring all the innovation to these databases that make building applications easier. So for instance, for Postgres, our team contributed improvements to Postgres 14 in the area of connection management, improving the availability on some benchmarks by up to 2x through these improvements. This helps all Postgres running anywhere, in any cloud, in any environment. But again, because we were the ones who built it and we know how to operate it, we're the ones who are able to provide the best service on Postgres. A measure of success for us for Postgres is how quickly can we support community releases in our service. So for instance, for Postgres Hyperscale, for Postgres 14, 1 day after the release of the community edition, we supported it in our cloud. We expect the same for PG 15, which is coming up. Similarly, I talked about availability investments. We're investing in availability for Postgres, working to both improve the service infrastructure as well as improve the underlying Postgres engine to manage upgrades at scale and to make all aspects of availability just work. I talked a little bit about Postgres Hyperscale. It's a distributed database service for highly scalable workloads. Our goal is to provide the same it just works scalability and elasticity that customers expect from Cosmos DB for Postgres workloads. So for instance, we've recently invested in no interruption partition splits for Postgres Hyperscale. So an application doesn't need to think about what to do or when to split or how to scale with that. And as I noted, Hyperscale doesn't compromise on Postgres support. All the extensions work, and as soon as community editions are released, which we've participated in building, we support them. And just like SQL, we're working to provide support for Postgres everywhere. Postgres Hyperscale Arc is in preview, and it's released in open source for people to deploy anywhere using the Citus extension of PostgreSQL. And you'll see this continue as we enable Arc for all of our products and services. Talking about scalable and distributed systems, we've definitely seen a rise in the popularity of NoSQL databases. Azure Cosmos DB is our offering in that space. It supports APIs, Mongo, Cassandra, Gremlin. And Cosmos DB is really foundational for Azure and for Microsoft. Services like Teams, ARM, Azure DNS, all depend on Cosmos DB to provide this amazing, it just works, global availability and elasticity. And we've been continuing to invest in those capabilities. From identifying situations where during a regional outage, the system just doesn't automatically address any problems, to situations where during upgrades, there are small changes in query performance. So we're working to get more and more customers to be using these services in their full it just works capability. For instance, using things like serverless in Cosmos DB. Now 40% of workloads in Cosmos DB use serverless. We want to get that to 100%, as I mentioned earlier. We also have investments in multi-region and multi-master. We want all databases to be multi-region and multi-master so that wherever your write is, it will just work. So we want to now give you a little bit of a look forward into some new capabilities we're investing in to make the developer experience easier. So for that, I'd like to welcome Davide to the stage to talk about GraphQL support in our database systems.
Thank you, Peter. Hi, everyone. I'm super happy to be here to show a first look of something really cool that we've been working lately in the last years, I would say, on making the databases more easily available to everyone in a absolutely modern way. And so what we have been building is the ability for each database in Azure, be it Azure SQL Database, Cosmos DB, Postgres, MySQL, or MariaDB, to be exposed or to expose its data and its object as a REST or GraphQL endpoint automatically. And this will enable, I believe, an amazing increase in productivity and efficiency for developers, because basically we will take care of everything for you if you wish us to do so. For example, scalability, ability to scale out security. So you will be able to just say, this table, this collection needs to be exposed as a REST endpoint or a GraphQL endpoint, and that's it. It's done. And why this is important? I have a demo for you to show. Let's start with a super simple application, a to-do list application. Today, even this kind of simple application needs to work with web application, on a desktop application, or on a mobile phone. And to build such architecture, you probably will build something like that, right? A front end with a back end and a database. And the front end and the back end will actually communicate using JSON, and then the back end is just basically translating whatever request it received to the database. Now, what if we take care of the back end for you? What if we automatically create database from database, the backend for you, by taking some information you will provide us, or even a GraphQL schema if you're using Cosmos DB, and then crunch it together and build a fully supported GraphQL schema so that you can do basically what I will be showing you right now. Let's say that you have a table, a to-do table, super simple. And of course, it has some columns and some data, so nothing strange, usual. I'm not doing anything different or other than the usual. You see, I'm inserting some data already. And I also have a category because I also want to have a relationship with other tables, right? And so I'm also building the relationship. And in this case, I'm even building a foreign key to give in even more metadata to my system. And then what I'm doing is just proving you that this is a regular table, no changes. Now, this is the configuration file you have to give to Data API Builder in order to allow the engine to know that we want to get the to-do table and expose it as an object called to-do that will be reachable via REST or GraphQL right away. So you just have to provide also information about which kind of relationship you want to surface so that you can navigate it using GraphQL, and security. Right now I'm just using anonymous security so anyone can access to it, but of course there is an extensive support to secure each item in the table so that only the proper people will be able to access to it. And then you just start Data API Builder, and in a few seconds, you have the REST endpoint available for you. So you can already start and query the REST endpoint, for example, listing all the data. And you can also, of course, then get a specific item because we support a lot of options to allow you to interact with the data. You can create a new item, and you can even use Graph, even with complex queries like having a relationship and navigating the relationship. Again, right away, you just deploy Data API Builder, configure it, and everything is ready for you. And as you can see here, I'm navigating the relationship, even providing query internally to the relationship, and I will just execute my HTTP request, and that's the data in your database. So this is amazing because as a developer, if you wish to just use Data API Builder to allow you, allows us to access your data, well, that's it. You even have the mutation in GraphQL to even update your data. And so this really means that you can focus on building everything else, right? You can build, for example, a super nice front end. Here in this case, I'm using Vue, a very common JavaScript framework. And all I need to do is spend my time building the most amazing experience and performance for my user and just use the regular JavaScript I would normally use to query my endpoint. And in this case, I'm just using plain JavaScript, no library, but then I will show that we can also use, for example, Apollo, a very famous GraphQL library, to send a GraphQL query. And the only thing I needed to do is just to focus on my Vue front end, my experience, or the experience I want to provide to my users, and that's it. My application is there running. All the data you will see is now taken from a database thanks to this REST endpoint, exposed, and it's working perfectly. Now, this was for Azure SQL. What about GraphQL and, for example, Cosmos DB? Well, we support it too, because as said, it will work on all the databases that we have. With GraphQL and Cosmos DB specifically, of course, you need to specify a model or some GraphQL schema, because of course Cosmos DB is a NoSQL database, so you need to provide the schema with a GraphQL schema file, and then you provide it to the engine, and then again everything is the usual. You have a configuration file, you specify the entity you want to be available as a GraphQL endpoint, and here you go, GraphQL for you for free with all the support of filtering, navigating relationship, and everything you would normally have to do by hand. And this means that you can use mutation, for example, to create, update, delete any entities in Cosmos DB in this case. And the result is just a document in Cosmos DB, just like you would have done by yourself. And this example that my colleague Saji created, this is in Angular and is using Apollo client to query the GraphQL endpoint, and it's just done. I can focus on my GraphQL and an Angular design, and basically have my application done. Queries running behind the scene for me, everything is taken care, and we will automatically even scale out the engine depending on how much workload you will put on it. I think this is great because this will improve efficiency and developer joy by a lot. And with that, Peter, is back to you now. Hope you like it.
Thank you, Davide. As a database guy, it's always I feel a little that you can't see the database here. Where'd the database go? Did I need a database at all? But it is wonderful to see the enhancements this will enable and the ease of building applications. And then all the stuff on the back end about performance and availability and scale like that, we can worry about it and you don't have to. That's our goal. So hopefully you found it useful to learn a little bit about what we're doing and where we're investing and how we're making it easier to build data applications. So I wanted to end by sharing 2 data points that we're proud of. Number one in the Gartner Magic Quadrant for cloud databases. We're in the leadership category and top right. And second is in market share, where we've passed Oracle after 25 years and consistently been larger than AWS and GCP. These kind of indicators are actually trailing indicators of success. The leading indicator is actually the satisfaction and success of developers in building applications and evolving them to use their data. So today you've seen how Azure databases are ready for any application or workload you want to build. And so I'm really excited to see what all of you sitting here are going to do to build with them. So, we innovate and invest based on what everybody in the room here needs. So my ask for you today is to go out and do these and keep building what you want to build and keep pushing the envelope on what's possible. And, let us know what you need. Also, let us know what you dream about. What would you wish? Maybe you would wished for that GraphQL endpoint for databases, and I can tell you we're ahead on that. We got that one. So the goal is to make building data applications really easy and just work. And please go forth and try and do that, and let me know what you need to do that. Thank you.